Okay, so we are going to start in our trigonometry unit now. So this is going back to some geometry that you've learned. And the first thing is, if we've got a right triangle, I'm going to label the top angle here A, B, and then C is going to be my right angle. And that's just so that I can know what I'm referring to. And our convention is that if this is angle A, the side across from it, we use a little letter, same letter, but lowercase. So if that's angle A, this is side A. This is angle B, side B, angle C, side C. And if you remember Pythagorean theorem, what did it tell us about our sides of the triangle? It told us that A squared plus B squared equals C squared. So we have to keep that in mind, right, so that we can identify our different sides. The other thing that we also know about a right triangle, if this is 90 degrees and the sum of the triangle's angles are 180, so capital A plus capital B must equal 90 degrees because these two together have to equal 90. When we add with this 90, we get 180. Okay, and there were some special ratios that we have in a right triangle. And what this is saying is the sine of angle theta. And theta is just going to be generic for whatever angle we're talking about. So the sine of angle theta is equal to the opposite side divided by the hypotenuse. The cosine is equal to your adjacent side divided by the hypotenuse, and your tangent is equal to the opposite side divided by the adjacent side. Oops, that should be an A, adjacent side. We also then have the inverse, or the pairs of these. So CSC stands for cosecant. Cosecant is simply the reciprocal of sine. So cosecant of angle theta would be your hypotenuse divided by the opposite side. Secant is the reciprocal of cosine. So that would be the hypotenuse divided by your adjacent side. And COT is cotangent, which again is just the reciprocal of tangent. So it's the adjacent side divided by the opposite side. And I don't know if you were taught this or not, but an easy way to try and remember sine, cosine, and tangent is SOHCAHTOA. Sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So whatever way you want to remember it works, but SOHCAHTOA is the way most of us keep track of all of these. Now, why do we care about these? We care because they help us find all the different angles and sides of a triangle. So for instance, if we have this triangle right here, let's shrink this down a little so you can see the whole triangle. I'm given one side is 3, the hypotenuse is 5, and this is called angle theta. Okay, so if this is my triangle, again, I'm going to call this, let's call this angle A, B, and C. So I don't know the side A, but if we remember our Pythagorean theorem, A squared plus B squared, so that's 3 squared, equals the hypotenuse squared, so that's 5 squared. So A squared plus 9 equals 25. If I subtract 9 from both sides, I get A squared equals 16. So A must equal 4. So now I've got my different sides, 3, 4, and 5. And when I'm trying to find these trigonometric functions, I have to remember which angle I'm using. So I'm using this as my theta, angle A. So the sine of theta is the opposite over hypotenuse. So it's opposite of this angle. So that would be 4 divided by hypotenuse. So 4 over 5. The cosecant, again, is just the reciprocal of that, so 5 over 4. Cosine is the adjacent side, so that would be 3, over the hypotenuse, so 5. 3 over 5. The secant is the reciprocal of this, so 5 divided by 3. And finally, our tangent. The tangent we find by the opposite side divided by the adjacent side. So opposite side is 4, adjacent side is 3. Cotangent is the reciprocal, so 3/4. Okay, let's do another example. In this case, we're given a equals 3, b equals 2. We need to find c, the missing side, plus angles a and b. So the first thing I like to do is just let's draw one. It does not matter if it's to scale or not. So c is always going to be your right angle. I'm going to call a the angle up here and b over here. I know c is my right angle. I'm given that side a is 3, so that's got to be the one across from angle a. I know that b is 2. So the first thing I want to do now is find side c. So c, we use the Pythagorean theorem because we know two sides of a right triangle. So 2 squared plus 3 squared equals c squared. 2 squared is 4, plus 9 equals c squared. So 13 equals c squared. Okay, so if I square root both sides, I get c is equal to the square root of 13. And I would rather you left it under the square root sign. That's much more exact. So we now know this side is the square root of 13. Okay, so I know all three sides of my triangle, and now I want to find a and b, those angles. Well, I know together they add up to 90. So I've got to find some way to find them. And it doesn't matter how we do this. I'm going to use angle A to start with. So angle A is equal to, well, let's see what functions I know. If this is angle A, I know that the sine of this is equal to 3 divided by the hypotenuse. So I could say the sine of A is equal to 3 divided by the square root of 13. If I'm trying to find A itself, I have to do the inverse of sine to get a by itself. So a is equal to sine inverse of 3 divided by the square root of 13. I'm going to have to use my calculator to do this. And the very first thing we should do on the calculator is make sure that we are in degrees, not radians. Because our calculator, if you go to mode, notice down here, that third line, radian is highlighted. We need to switch over to degree and hit enter. We want our answers in degrees. So then quit. So now I want sine inverse. So we see our sine button. Oops, you don't unless I put it up here. Here's sine. I want sine inverse. So I do the second sine. And in here I want to do 3 divided by the square root of 13. Come out of there and enter. So we've got 56.30999. I am perfectly happy with one decimal place here. So A equals 56.3 degrees. Okay, so if I know angle A, we know A plus B must equal 90 degrees. So 56.3 plus B equals 90. Let's do this. So 90 minus 56.3, angle B must equal 33.7 degrees. So we've now found everything we've been asked to. We've got our side C, angle A, angle B. That's the rest of the notes. I'm going to do a couple of examples now just on the next video of how to find some different things.